Hi, my name is Vinay, and in this video we will draw and layout for a CMOS NAND gate using a Microwind 3.8 software. So in the schematic we have seen this is how and NAND gate looks like. So you have two PMOS and two NMOS, 10 MOS are in series and PMOS are in parallel. Okay, so we will implement as per the guidelines. So we have to draw a layout of NAND gate with WP by WN ratio 40:2 or 40:20 or 1:2 is the ratio. Okay, and we just see the observations. Okay, so I'm using a 45 nanometer CMOS technology of Microwind because that's what I've seen done in schematic. So let's make okay, here I've set the width as 0.4 and 0.4, all of them are of the equal width, but here I can change it in the layout. So come back to layout, I have clicked on mouse editor. So I just make it maybe 800, okay, PMOS, okay, and I will use finger technique. So that is an optimum way of making the layout where the two transistors are placed adjacent to each other. So that is 800 nanometer or 0.8 micrometer long, and I will make the NMOS half of it. So I will make it 400, and NMOS will be also of two fingers, and place it somewhere downside, yeah, over here. So here there are two PMOS transistors connected side by side, okay, and I just make the formalities. So I take the metal one. So if you want to use the transistors parallel, so they are already in parallel. If you join these two nodes, if I just take this nodes above and take a horizontal loop and connect with this one, so that will be one entry node and this will be the exit node point. Okay, so that transistor will become in parallel. So I just bring it down. Okay, maybe I just shift NMOS a little bit down so to make a spacing, yeah, and this would be my output node, and for NMOS are in series, so I will just connect this node to the output node and this node will be unused and this would be the VSS. So I just connect the VSS to this one and VDD to this terminal and VDD for the envelope. Now I have to join the gates, so I take the mouse gate and draw a layout like this, or you can use the stretch and move option and extend this. So our layout is ready. Now we are ready to simulate this. We can even load the output, so we can just add a virtual capacitance of a small value like 0.1 picofarad and label the output as S1 is okay, and take a clock and connect to one of the inputs. So let's call this as B, and time high and low is 1 nanosecond. And another clock, call it B. So time low and high are 2 automatically. Okay, so let's change the background and see the simulation. So this comes very dense. So here we have for delay of 337 and rise time 64. But I would suggest to configure the NAND gate as an inverter because that you will get the real performance out of it. So to that, you can set any one of the input as VDD. Okay, so you just double click on the node and go to DC supply and connect to VDD, assign it, and then you can simulate again. So here what you see, this guy is working as an inverter. So here you see the rise delay, low to high delay is 138 and high to low is 337. That is because obviously the width of the NMOS is smaller, hence you get higher delay at the output because the driving strength of the NMOS current transistors is less. Okay, but you can try making the NMOS as equivalent width of the PMOS, and thereby you will get almost equivalent gate delays at the output. So guys, this was about CMOS NAND gate. Okay, thank you very much.